Why do buildings fail in earthquakes? By Alden Tetreault. When an earthquake occurs, buildings tend to collapse and crumble to the ground in pieces. This leads us to keep asking the same question: why do buildings fail in earthquakes? During an earthquake, the ground can shake in either an up and down motion or side-to-side motion. This also causes the ground to break and crumble as well as buildings. The shaking of the ground makes the building sway back and forth and may damage this building structure or make the building collapse. The greater the shaking is, the more damage is suffered by a building. Small buildings are greatly affected by high-frequency waves, which are short and come frequently. Imagine that you're on a small boat in the middle of the ocean. When waves are big but come less frequently, you will not be affected on the boat. But if there are several small waves that arrive frequently, the boat may tip over or capsize. This is the same theory we use for deciding which waves affect buildings that are different heights. If a building is tall or has a large structure, it is more likely to be affected by low-frequency waves. Imagine that you're out at sea again, this time on a very large boat, as in a cruise ship. If a large number of short waves come in a small amount of time, the ship won't be affected because of its size. But if the waves come that are bigger in size and spread apart, they will affect the ship more. Buildings that are located in earthquake zones, which are places where earthquakes occur commonly, should use building material that will bend but not break. Steel is usually the best for this job, but wood may also work because it bends more than concrete. In this picture, the red represents places where earthquakes happen often. The orange is places where earthquakes occur commonly, but not as much as some areas. The yellow represents places where earthquakes usually don't happen, but may still pose a possible threat. Lastly, the green represents places where earthquakes rarely happen. One way to make buildings safer is to add base isolation. The first technique using base isolation is to place rubber mounts under the structure of the building. If an earthquake were to occur, then the earth would move under the structure, but wouldn't affect the building itself. This also helps the building because the rubber mounts absorb part of the energy the earthquake releases, before it can get to the building. The second technique involving base isolation is to use a material that is able to slide. This isolates the movement of the building while letting the ground underneath the building move. This technique was used in the Japan earthquake of 2011 to help make sure that the buildings wouldn't collapse. Sometimes a large damper is put onto the tops of buildings that are very tall, so that it can counteract the movement of the ground. A damper is the device that is used to get rid of energy that an earthquake releases and to reduce the shaking of a building. In Taiwan, the second tallest skyscraper, Taipei 101, uses a damper at the top of the building. Thanks for watching!